Okay, so we are working through question 6. Let's give it a read. A rectangular sheet of cardboard has a length of 80 centimeters, a width of 50 centimeters. Squares of a side length x centimeters are cut from each of the corners as shown below. So here is our rectangular sheet of cardboard. It has a length of 80 centimeters, it has a width of 50 centimeters, and as you can see here, we have squares of a length of x centimeters cut from each of the corners. We continue reading. A rectangular box with an open top is then constructed as shown in the diagram below. Here it is right here. So after we've cut out the squares, we are then folding it up and creating this box. Let's now get to the final part of our question, which says the volume of the box is a maximum when x is equal to what? Okay, so we are obviously doing an optimization question. The key giveaway is the word maximum. We're finding the maximum volume. So obviously the first thing we are going to want to do is find the volume of this box. And because we want to find when x gives me the maximum for the volume, I'm going to be finding my volume in terms of x. So that means I need to figure out what the height, the length, and the width of this box is going to be. The way we're going to determine that is by looking at our diagram here. So we are cutting out these squares from each of the corners here. We're cutting out these squares from each of the corners. So if you can imagine cutting these out and then folding up your box, hopefully you can appreciate that the height of the box is going to be x centimeters. Moving on, we now need to figure out what the length of this box is going to be. What we're first going to do is just kind of appreciate for a moment that this right here, these are all x, right? We're cutting out these squares here, so they all have the same side length of x because they're squares, right? So with that piece of information, we can say, well, my length is going to be this, which will be 80 minus these two regions here, 2x. So that will correspond to my length right there, 80 minus 2x. Then we keep on going. We can now figure out what my width is going to be. My width is going to be this right here. Knowing that the whole width here is 50, we're then going to minus 2x from that. So 50 minus 2x, which means this right here is 50 minus 2x. We can now write down what our rule for the formula is going to be in terms of x. It's just going to be this times this times this, height times length times width. So x times 80 minus 2x, then 50 minus 2x. Now, let's see if we can kind of create a domain for ourselves as well. Let's look at the shortest side, so my width right here. Now, what we know is that this is going to have to be greater or equal to 0, right? Because we can't have a negative width. In the real world, that doesn't make any sense. If we now rearrange this, what we're going to find is we end up with this, and then finally, we're going to end up with this. So my x has to be less than or equal to 25 if I want my width to be greater than 0. So what I can say in terms of my x is that my x is going to have to be between these values right here. It has to be greater than 0 but less than 25. And if we were to let x equal 25, if you look here for a moment, 50 minus 2 times 25 will be 50. 50 minus 50 is 0, so the volume would be just 0. If we were to make it any bigger than 25, I would end up with a negative volume, and that simply doesn't make any sense. So that's why we've said that. Okay, let's now go and put all this information into our CAS calculator, because what we are eventually going to want to do, because we are dealing with finding the maximum, it is an optimization question. So eventually we're going to have to differentiate this, set it equal to 0 to find my stationary points, and then we can determine what my maximum will be. So let's now just bring this all to the side because we're going to have to put that information into our CAS. We're going to come here and I'm going to begin by just defining what my volume is going to be. So V of x control equal is going to be x multiplied by 80 minus 2x multiplied by 50 minus 2x. I hit enter there. That's now done. What I'm now going to do is I'm going to go menu, algebra, solve. I'm going to go shift minus to get the differential there, x. I'm going to put v of x. I'm going to set that equal to 0, and I'm going to solve for x just like that. So I'm differentiating the volume, I'm setting it equal to 0, and just like that, I'm finding my stationary points of 10, and 100 over 3. Now, as we said, my x has to exist between 0 and 25, so that means we can exclude this. This would be 33.3333. We can just ignore it because it's greater than 25. So that means my answer is going to be 10. So we can come over here, and as you can see, let me get my highlighter out for this big moment. My answer is going to be A, which is just 10. Now, let's say you weren't 100% sure on all this differential stuff. What you could do is you could just go to your graph for a moment, graphs, and you could go, let's graph v of x. We're just going to have to make that fit for a moment. Windows, let's just make that fit. And now we have this right here. So this graph right here represents my volume for the box, and my axis here is my x, so it's in terms of x. If I now go menu, analyze, what's the maximum of this from here to here? As you can see, it's 10. That's what we found. The other stationary point that we found was 100 over 3. That looks like it's in that region right there. So that region, as you can see, is a minimum. We don't want to deal with that. And also, as you can see, it's negative. So it doesn't even make any sense. Because in the real world, you can't have negative volume. That just doesn't work. So as you can see, that's kind of just another way of visualizing what we're doing instead of just kind of dealing with this stuff. But hopefully that all made sense to you. Let's now look at the examiner's report. So this is question 6. Question 6, answer is A. Question 6, the answer is A. 63% of the state got that. Hopefully you found this video helpful, and I'll see you in the next video.